Good morning, guys. So this toolkit is on Vertex form. This is Vertex form, and I want you to make sure you have a label in your table of contents, and a date. Make sure you put this in your table of contents, okay? So, Vertex form is right here. The easiest way to graph a parabola is from Vertex form. And so when we talk about it, we can identify the vertex very easily. H, the number inside the parentheses, is the opposite. So this is a negative sign, making it the opposite of H, whatever you see there in the parentheses. So the vertex in this one would be 5, of course the opposite of the number in the parentheses, and negative 23. K is the Y value of the vertex. And that is the reason why it's so easy to graph, is because once we have the vertex, we can use our table, as we learned when we graphed parabolas, to do the rest, okay? We're not going to focus on graphing very much in this toolkit, though. We're going to focus on putting it in this form, okay? I'm going to be able to convert back and forth from vertex form to standard form. Tell me again, what is standard form? I hope we know that by now. So we have it equal to y or equal to 0, but standard form is this that we've been studying for weeks now. Really close to a month we've been looking at standard form for a quadratic. When we go to this step to convert it to standard form from vertex form, it's really pretty simple. We need to distribute this, so write it twice. We need to distribute, and then at the end we'll just subtract 23. Okay, we'll just keep that on the end until after we've distributed. So x times x is x squared, but this is the box method or FOIL. X times negative 5 is negative 5x, negative 5 times x, negative 5 times negative 5, and then I add on that negative 23. Okay, so when we finish, I'd have x squared negative 10x when I combine those 5's, and positive 25 and negative 23 would just make 2. Alright, so that is standard form. If I'm asked to put something in standard form, that's all I have to do, is convert it by multiplying that out and then subtracting or adding that last number. Okay? The hard part comes in the next slide when I'm asking you to put it in vertex form. So we need to complete the square. You guys are pretty good at completing the square, I think, because we spent a whole toolkit on that already. But if I want to go from standard form to vertex form, this is how I'm going to do it. Completing the square, while what we're not solving is a little different. Okay, I am going to change that to a y, just to make it a little simpler to write. And I want you to think about what I'm doing in this first step, back to completing the square. Our first step in completing the square was to add a blank. But in this step, I'm going to add and subtract a blank. And the reason why I'm doing this is because everything is still on the same side of my equation. So in completing the square, we moved c to the other side of the equation, and we made both of those positive blanks. But when we're completing the square on the same side, we're adding and subtracting a number. And when we add and then subtract the same number, we're not changing the equation at all. It's still going to be the same graph of the same function. It's just moving it to a different form by adding this number and making this section a perfect square trinomial. Okay, once you get the hang of this, it's not that much different from completing the square. What number normally goes in those blanks? B divided by 2 squared. So in this problem, B is 8. So I'm going to say 8 divided by 2 is 4, squared is 16. Okay, so in those blanks, I'm going to put a 16. And again, if I add and subtract a 16 from the same problem, I didn't change anything. All I did now was make this section, I realize I just marked out my problem. This section, I'm going to redo that, a perfect square trinomial, okay? Because when I factor 16, the factors of 16 that add to be 8 are 4 and 4. And then I'm going to simplify this part on the outside, and that's going to become k. 11 minus 16 is 5, negative 5. Okay? When we simplify this part, we write it twice. So we can write it with a squared. Look, it's in vertex form. Okay? This is not too scary, again, if you're good at completing the square and you got those steps in your head already. So, notice what's missing. There's no a here. In completing the square, we talked about only doing completing the square where a was 1. If there was a GCF in the original problem, we would want to factor that out. I'll do an example like that at the very end. Okay, but if there was a GCF, that's where we'd get that a right there. Okay. All right, let's do example 2. In example 2, we just have the same type of problem. B is 6, C is 8. We're going to move that over and add our blanks. Add. 8 stays right there. Remember to put that plus sign there and subtract. Again, this needs to be a subtraction. This needs to be a subtraction, or you're going to mess up the problem, okay? B divided by 2 squared. That's 3 squared is 9. Okay, so if I put 9 in my blanks, if I factor this, I'd have x plus 3 and x plus 3. And negative 1. If I subtract 9, again, this part is what you're factoring. Okay, this part is going to become k. Once you have written that, we can square it. Remember, they're supposed to be the same thing. And then we're in vertex form. Okay? In these next two examples, I got a little bit of complication. Example 3 is because there's a GCF. In example 4, there's no C value. So example 4 is kind of weird also. Example 3, there's a GCF. So the first thing I want to do is factor out that GCF. After that, I'm still just doing the same thing I did on the last slide and converting it to vertex form. I just got a weird 2 on the outside of my parentheses. Still doing the same thing with adding blanks, subtracting a blank. That part remains the same. What goes in that blank is negative 6 divided by 2 squared. Okay, I have negative 3 squared, which is a positive 9. Positive 9. Remember, just because we square a negative doesn't mean it's a negative. Be careful. But when we factor this, it becomes x minus 3 and x minus 3. Now this next part is weird. It's hard. You see how this part is inside the parentheses in this step. It would become a negative 1 if I subtracted. But it's inside the parentheses that are multiplied by 2. I know that's weird. So since we have to take it outside the parentheses, it was a negative 1 on the inside of the parentheses, but then I took it outside the parentheses, I have to make it a negative 2. Okay, I know that's hard. There's not one like this. on your practice, if I remember correctly. Okay, that is my standard form when there's an a value. Okay, a little bit harder. This one's actually easier, it just looks weird. Okay, so if there's no c value, there's no number right there. Okay, there's no number right there to add or subtract a blank from. I'm just going to add or subtract the same blank. Add a blank, subtract a blank. Okay, there's just no c. What goes in that blank is still the same. 4 divided by 2 squared is 4. Okay, and we factor that. And we still have a 4 on the outside. And this is my final answer. So this one, not scary, just kind of different. Okay. In the next slide, we are going to try one by yourself. And I want you to try this one, get it all the way to vertex form, and then we will go over it, and you can handle the practice. Pause the video, try it by yourself. Alrighty, I hope you got it. When in this problem, I had to add 25. Again, we're only factoring this part. Okay, only that part. At the very end, I might ask you to identify the vertex. What is the vertex? Remember to change the sign on the inside. Change the sign on the inside of the parentheses, and that 9 stays negative. This format is really the format that you're thinking of in vertex form. So H is the opposite of the number inside the parentheses. You can do it. Good job, guys.